the Algonox official channel. So today we will be talking about ASC Builder and how the interface works, how to navigate through the graphical user interface. So the ASC Builder is a GUI drag and drop smart contracts development tool that helps you build smart contracts for Algorand. So it typically compiles the GUI to PyTEAL code, which in turn could be compiled to TEAL and then deployed to MainNet, TestNet, or BetaNet. So this is the landing page, and this is where you would be able to have access to your account or create one. So I have my account, so I'll just hop into my account and then we'll head straight to the GUI. So this is the home page, the dashboard home page, where you could see a list of your created projects, and you could create a new one using a template or importing a JSON schema from a previously created project. And we could go to the settings page. So this is where you could update your username that could be used for uniquely identifying your account. Then we have the billing page where you could see everything that has to do with your billing and transactions on the platform. So with this page you could deposit algos, which could be used for charging for compilations, and you could see your seed phrase. So what happens is, anytime you create your account, anytime a user creates an account, there is a wallet address assigned uniquely and specifically to each account that could be used for billing, as in paying for transaction fees and compilations. So on this page you could view your wallet on Algo Explorer, or you could deposit algos and see the number of transactions left for your account and compilations. So what we would first do is to create a project. So I'll just call it a simple application. Okay, so once the project has been created, we could have a look at the interface. So this is how the editor looks like. There are several components that you could use to build your smart contract and get up and running. We have the status bar, and we have the configuration tab, and on the menu bar we have methods, we have variables, we have nodes, we have global states, and we have the compile tab. So the simple application at the top of this menu bar, we have the name of the project, which could also be edited and updated. And for the configuration pane, we have properties, variables, and globals. So the properties tab helps you to view details and information about the currently selected components on the screen. And we have the variables section that helps you to add variables, more like data placeholders for your project. And we have the globals tab. That is where you could add global states that would be created upon the deployment of your smart contracts. So we would start by navigating through each of the items on the menu tab, and we would know what each of them does. So first of all, for every project, we could actually talk about the methods. For a method, it's like a root in your application that represents a callable fragment of your application. where you could actually perform a unique or specific action for your project. So for every method, you could actually specify the behaviors and attributes of the method that would help you to streamline your application and build it to your taste. So typically a method could be simple method. For instance, now once you look at the right side of the screen, the properties tab, and you've selected the method, you'd see the property of that widget. It tells you that it's a method and the name of the method is simple method. So basically we could create a little project, but before we do that, we have to know about each of the other components or tools for the editor. So we have the variables. So a variable represents a simple data object that holds different forms of data, that stores different forms of data. So it could range from addresses, assets, byte strings, or byte slices, as you may know for PyTEAL. We could talk about integers, asset holdings, minimum balances, asset decimals, arguments, applications, transaction fields, group transaction fields, miscellaneous variables. So miscellaneous variables are variables that perform transforms on other variables, like arithmetic operations and byte slice operations and integer operations. So we have local states, we have global states, we have external local states, we have the external global states, we have a global field, and we have the transaction type, which tells us if it's an application call, if it's an asset transfer, an asset config, or any other form of transaction. So we have the node. So the node is like a simple fragment of your code that performs any that can be used to perform any operation or any event. So a node, take it as a flow object for your code or smart contract. So we could create a decision, a condition, an unconditional or conditional met, routine or action node for the project. And then we have the global state. So the global state is can be created as a byte string, an integer, an address. So a byte string global state and an address similar in the sense that the address is also a string, it's a byte slice. It could be attributed to the same data objects. And we have the compile. So the compile tab is where we have an export object that could help us to export the project into a JSON object or schema that could be imported in another account. So in that case, once imported, the wielder of the other accounts can have access to the project and modify it to their taste. So we also have PyTEAL. So the option for PyTEAL helps you to compile your GUI into PyTEAL code, which could also be deployed as well once that is done. So now that we are done with talking about the components of the interface, we would attempt to make a little program that accepts a sender, and it accepts the sender to be only the creator, and it would typically just approve the program or reject it if that is not the case. So a simple method is typically made up of a decision, and then a decision is made up of two other fragments or one, depending on how you want to structure the decision. So in this decision, we would want to say that we would want to create some variables that will hold the creator address and the sender or caller of the method or application for this particular method. And a simple variable, we would have to select the method we want to create the variable for. So when we create the variable, in this case we would have to create an address variable, and we would call it TXN sender, and we would let it be the sender of the transaction. So once you create a variable, it gets displayed or added to the variable section of the screen, and the variable section of the screen shows you the method that the variable is attributed to and the computed value, which is in this case is the TXN sender, which is equal to the TXN.sender. That is the caller of the application for this method. And we want to also create a variable that would hold the creator of the application. So we have the creator address to be the creator of the smart contract, and we could also now structure our decision. So once we have the two variables here, which are the creator address and the sender of the transaction, we could do a little decision that would approve the transaction only if the creator of the application is equal to the sender, and it would reject the transaction if that is not the case. So we'll dive back to our decision. So a decision is made up of two main nodes. So the arrangement of the GUI components is in a tree form, where we'd have parent and child nodes. So a decision would have a condition, it would have a met node, and it would have a routine node. So a typical decision is made up of two components, which is a met node and a routine. Now for this structure, we have it that if a particular condition is met, then this is the line of action to take, else this other routine would be acted upon. So once you have this basic structure, you could then go into the first node here in the decision, which is the met node. So a typical met node is meant to tell you that if a condition is met, then we would have to perform a line of action. So we would add a condition. So a met node then takes either a condition, an unconditional, or an or conditional. So we could, if you want to group a set of conditions together that each have to be met at once, you would use an unconditional. Then if you want to use a set of conditions in which if any of them is met, you proceed with the execution, you could use an or conditional. So in this case, we just have a single condition, so we just add a condition node. So a condition node helps you to compare two operands or two variables, for example. So you would put the name of the variables. So we want to compare TXN sender to creator address. So the operator we want to compare them with is an equal to operator. So we want to check if the first operand rather is equal to the second operand. So there are other conditions we could actually check for. We could check for is not equal to, is greater than, is less than, is greater than or equal to, or is less than or equal to. So in this case we have is equal to, and then we need to add a routine to the met node. So the simple structure here is, if we have a decision, we have a met node and a routine. So this is like, if this met node contains a condition and that condition is met, the other routine that we'll be adding to the met node has to be executed. So once we add a routine, this is what will be executed if the condition in this met node is met. So a simple routine has an action or set of actions that have to be taken once they are completed. So we would add an action node. So when creating an action node, you have to select what kind of action you want to perform. So there are a wide variety of actions that can be performed, like sending algo, sending an asset, opting an asset, writing to global states, writing to local states, removing a global state, removing a local state, approving a transaction, or rejecting a transaction. So in this case, we just want to approve the transaction, since the TXN sender is compared to the creator address with the equal to operator. And then in that case, we could also go back to the else routine. So the else routine would have an action, which would be simply to reject the transaction. So we could add the node. So we have our simple root setup, where we have a decision that implies that if the sender of the transaction is equal to the creator, then we approve the transaction, else we would reject the transaction. So if you look at the properties pane at the right, you would notice that anytime each of these nodes are selected, the properties will be listed at the right to let us know what kind of node it is and what it does on the screen. So since we are done with creating an application, we'll explore the other parts of the code, which is the compile. So the compile is going to let us to compile our code to PyTEAL. So we'll be generating our PyTEAL code now. So we have a PyTEAL program, and in this program we can see that the decision is created and we have approved the condition here. If the TXN sender is equal to the creator address, else we've rejected it. So with having this code, the other attributes or features of the application we would have to explore are the copy to clipboard and the deploy. So we could click on the deploy. So the deploy helps us to push our application or deploy it to MainNet, TestNet, or BetaNet. In this case, we'll just use Algo Explorer. You could actually add arguments that you want to call the application with, but in this case, we'll just proceed to deploying the smart contract to TestNet. So we'll be presented with a window that will let us to sign a transaction for application creation. So the transaction is being submitted to the test network, after which the application ID and the application address will be displayed. So we'll just copy the application address to check it out on the blockchain explorer. In this case, Algo Explorer. So we copy it to clipboard and paste on Algo Explorer. So we have that it is an application. with the ID here, and we would see the block timestamp and the block it was committed on, and we'd see the state schema. And we could also explore the PyTEAL code and other transactions that have to do with the application. So having navigated through the interface, we would have to talk about creating some simple applications using the tool, and we hope to see you in the next video where I'll talk about creating some simple applications like a simple counter and how we could deploy to the MainNet or TestNet or BetaNet. And we'll also explore other features that ASC Builder has to offer. So thanks for watching, and hope to see you next time.